This is SpaceTime, Series 20, Episode 33. Coming up on SpaceTime, new evidence for antimatter in space, new details on how the late heavy bombardment changed the solar system forever, and a jet stream discovered in Earth's core. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists may have detected particles of antimatter helium in low Earth orbit. The early hints were spotted in data on cosmic ray observations undertaken by the Alpha Magnetic Spectrometer aboard the International Space Station. If confirmed, the discovery of antimatter helium could point to islands of antimatter spread across the universe. Confirmation of the discovery would also help resolve one of the biggest questions in astrophysics today, namely why the universe appears to be made up of mostly matter rather than antimatter. You see, equal amounts of matter and antimatter would have been produced in the Big Bang 13.8 billion years ago. Because matter and antimatter annihilate each other when they come into contact, the universe should have been destroyed just moments after it came into existence, leaving nothing behind but photons of gamma-ray energy. Now, this clearly hasn't happened, and astronomers don't know why. It could mean there's some fundamental unknown difference between matter and antimatter. Or it could mean that there are some regions in space, like where we are, which mostly contain matter, while others contain mostly antimatter. The problem with that idea, however, is that astronomers haven't as yet detected any excess gamma-ray radiation, which should have been produced in those border zones where antimatter and matter come into contact. Built by CERN, the European Organisation for Nuclear Research, the $1.5 billion Alpha Magnetic Spectrometer was flown to the International Space Station aboard Endeavour on STS-134, the penultimate space shuttle flight. The 8.5-ton instrument was designed to measure antimatter and cosmic rays and also search for evidence of dark matter, a mysterious invisible substance which can only be detected through its gravitational influence on ordinary matter. Since its installation in 2011, the Alpha Magnetic Spectrometer has measured the masses and electrical charges of some 90 billion particles. As well as the expected detections of protons, helium nuclei and free electrons, the instruments also detected carbon, oxygen and iron nuclei, as well as both antiprotons and positrons, the antimatter counterparts of protons and electrons. The larger than expected detection of high-energy positrons could point to the existence of a hypothetical dark matter particle with a mass of about 1 tera-electron volt. In astronomy and particle physics, electron volts are used as both measures of energy and mass, which, as Albert Einstein showed us, are interchangeable. However, the detection of a handful of heavier antimatter helium-3 particles would revolutionize cosmology. The candidate antimatter helium-3 particle comprises 2 antiprotons and an antineutron. On Earth, antimatter helium has only ever been artificially created in laboratories, and then only for a few fleeting seconds, and it's never been detected in space. There are only a few ways in which dark matter particles could possibly create antimatter helium. If confirmed, it could indicate particle interactions beyond the standard model, or alternatively the existence of islands of antimatter which have survived intact since the universe's birth. I'm Stuart Gary. This is SpaceTime. A new study of ancient Martian impact craters has provided the strongest evidence yet that the late heavy bombardment occurred between 4.1 and 3.8 billion years ago. The findings, reported in the journal Nature Geoscience, also shows a 400 million year lull in asteroid impacts striking the surface of the red planet. The study's lead author, Dr. Bill Bottke from the Southwest Research Institute in Boulder, Colorado, says the new results reveal that Mars's impact history closely parallels the bombardment histories inferred for the Moon, the main asteroid belt, and the planet Mercury. It means the early impact bombardment history of Mars has been linked to the bombardment history of the inner solar system as a whole. Borealis is the largest and most ancient impact basin on Mars. It's almost 10,000 kilometres wide and covers most of the planet's northern hemisphere. A study of Martian meteorites found on Earth, which were thought to have originated from the Borealis impact event, indicate Borealis probably occurred around 4.5 billion years ago. That's shortly after the planet Mars was formed, and probably out of the same accretionary material that formed Mars in the first place. Botke and colleagues found that the rim of Borealis was excavated by only one later impact crater, known as Isidis. This set strong statistical limits on the number of large basins that could have formed on Mars after the Borealis impact event. Moreover, the preservation states of the four youngest large basins on Mars, Hellas, Isidis, Argai, and the now buried Utopia, are all strikingly similar to that of the larger, older Borealis basin. Previous studies have estimated the ages of Hellas, Isidis, and Argai to be about 3.8 to 4.1 billion years old. The similar preservation states of Borealis and these younger craters indicate that any basins formed in between these events should have been similarly preserved. However, the authors have failed to find any other impact basins on Mars that could pass this test. It means the ages of impact basins on the red planet requires two separate populations of objects striking Mars. While the earlier impact period occurred just after the formation of the solar system 4.6 billion years ago, the more recent impact period corresponds to the 3.8 to 4.1 billion year timeframe for the late heavy bombardment. That leaves a 400 million year lull, often referred to by planetary scientists as the doldrums, between impact episodes. It's thought that the late heavy bombardment was caused by the gas giant Jupiter beginning its migration inwards from where it formed almost to the orbit of present-day Mars. In the process, Jupiter's powerful gravitational perturbations would have flung a great deal of material about. Meanwhile, the planet Saturn, which formed in the wake created behind Jupiter's inwards migration, then began dragging Jupiter back outwards again. That resulted in both Jupiter and Saturn ending up in their current orbital positions. And it was the gravitational perturbations generated during this outwards planetary migration by Jupiter and Saturn which flung material into the inner solar system, which astronomers now refer to as the late heavy bombardment. This is SpaceTime. I'm Stuart Gary. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. Scientists have discovered a jet stream churning deep in the Earth's molten outer core. Unlike the more conventional atmospheric jet streams associated with weather pattern-generated high-altitude winds, this newly discovered jet stream is located some 3,000 kilometres below the Earth's surface. A report in the journal Nature Geoscience claims the jet stream is caused by molten iron flowing along a boundary between two different parts of the Earth's core. As molten material moves towards this boundary from both sides, the liquid squeezed out sideways, forming the jet. The study's lead author, Phil Livermore from the University of Leeds, discovered the stream while examining data from the European Space Agency's SWARM satellites. Launched in 2013, SWARM is a constellation of 3 spacecraft measuring Earth's magnetic field. The planet's magnetic field is generated by the superheated molten metal swirling around the Earth's outer core as the planet spins on its axis. This turbulent convection of liquid iron acts as a geodynamo, conducting powerful electric currents which generate a planetary-wide magnetic field. The magnetic field travels from the core, through the mantle, crust and oceans and into the atmosphere, producing the Earth's ionosphere and its magnetosphere. Through the magnetosphere, the magnetic field plays an important role in shielding the Earth from cosmic radiation and the charged particles in the solar wind bombarding the Earth from the Sun. The SWARM satellites allow scientists to study the Earth's interior by tracking changes over time in the magnetic field from different locations in the outer core. The authors detected the molten metal jet stream by studying a pattern of bright high-latitude spots in the Earth's magnetic field. These magnetic flux patches are located in the northern hemisphere, primarily below Alaska and Siberia, and they make it easy for scientists looking for changes in the magnetic field. Previous studies of changes in the magnetic field had already indicated that the molten iron in the outer core was moving faster in the northern hemisphere, again mostly under Alaska and Siberia. Livermore and colleagues hypothesized that as the material flows along a boundary between two different regions in the core, it squeezed out sideways, forming a 420 kilometre wide jet-like stream of molten metal, moving westerly at over 40 kilometres a year, some 3 times faster than other material in the outer core. It's hypothesized that either buoyancy, or more likely changes in the magnetic field within the core, is generating the huge forces needed to move the metallic liquid towards the boundary. The authors estimate this metallic stream wraps halfway around the planet, and it's probably been in play for hundreds of millions of years. And what's more, they think this jet stream is actually speeding up. Livermore thinks the stream's behaviour could be crucial to the generation and maintenance of Earth's protective global magnetic field. The swarm probes could ultimately help scientists understand why the Earth's magnetic field has been weakening over the past few centuries, and whether that means that the planet's magnetic field is about to reverse polarity, with the South Pole becoming north and the North Pole changing to south. When the magnetic poles do flip, the authors speculate it could cause the jet stream to reverse direction. The geologic record showed that these polarity flips occur roughly every 200,000 years or so. And the thing is, we're already well overdue for the next flip, and that could affect the amount of charged particles reaching the Earth from space, which in turn could have a devastating impact on modern technology. To find out more, Andrew Dunkley's speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Amazing story about Earth's outer core and this jet stream phenomenon that they seem to have discovered.
Exactly. It's a fantastic thing, this. I just get staggered by the stuff that we learn every day by virtue of all the space experiments and all the research that's going on, particularly in this planetary science and astronomy. It is mind-blowing, and this one blew my mind when I read it. It's a bit of an analogue of the jet stream in the Earth's atmosphere. Near the poles, there are very fast, high circulating winds that whiz around the planet's poles, actually not that close to the poles, but they're concentrated, to the north and to the south of the equator, certainly. We're all familiar in Australia with pilots of aircraft telling us they've got in the jet stream, so you do it from Perth to Sydney in 20 minutes rather than the 4 hours or something that it normally takes. Likewise, there's a jet stream in the northern hemisphere as well, and that is used similarly by transatlantic pilots. They get up into the jet stream and whiz across from the United States to Europe. But how unexpected that in the other major fluid body on the Earth, which is the outer core of the Earth, there is another jet stream. That, to me, is mind-boggling, and I think it's a remarkable discovery. First of all, how has this been discovered? It's clearly not something you can go and tinker around with directly. The outer core of the Earth is about 3,000 kilometres beneath the surface. So the way the Earth is structured, we live on the crust, which is pretty thin, in fact. We sometimes call it the lithosphere. It's only 50 kilometres thick, something like that. Then there is this mantle, which is below the crust. That is a sort of plastic rock. It's rock that's fairly soft. Then beneath that is the molten core of the Earth. And the outer few thousand kilometres of that is molten iron. But in the centre, it's thought to be solid iron, because the pressure is so high that the iron resolidifies. And so what you've got is this kind of circulation between the solid iron core and the molten iron core. And we think that's where the Earth's magnetic field comes from. So to cut to the chase, the European Space Agency has a set of satellites which are called SWARM. These are spacecraft which work together, but they have very, very sensitive magnetometers on board. So what they're doing is mapping the magnetic field of the Earth and mapping the way it changes. And it's because of that that these discoveries have been made, that first of all, there is this rapid current jet stream which is basically under Alaska and Siberia. The odd thing is it's going westwards. It's not going eastwards like the atmospheric jet stream is going.
That's odd.
This one's going westwards. But I guess all bets are off when it comes to the circulation of the core of the Earth. The Earth's core, of course, is rotating itself west to east, but this, because it participates in the overall rotation of the Earth, but this jet stream's moving the other way. They describe it as fast, and by fast, they mean 50 kilometres a year, which sounds like a bit of a crawl, really. But in geological terms, that is enormously fast. It means this stuff is swishing around underneath our feet. 50 kilometres a year, of course, is a kilometre a week.
Yes.
So it is relatively fast. But the other thing is its width. They think this jet is around 420 kilometres wide, and they suggest it goes halfway around the planet. So it's really very important discovery in terms of the structure of the magnetic parts of our planet, the bits deep down. They suggest that this jet stream has been there for hundreds of millions of years, if not longer. And I guess what they are really looking for is clues as to why from time to time, and on a time scale of a few 100,000 years, the Earth's magnetism reverses. So what was the North Magnetic Pole becomes the South Magnetic Pole. That is something that's well established. We can tell from the sort of magnetic records in rocks, principally the ones deep down under the bed of the ocean. But the thinking is that it's caused by some sort of interaction between the solid core of the Earth and the liquid ion core, and that's actually why the Swarm spacecraft were launched, to try and investigate that. This is really the first discovery, and it is really a staggering one.
It is quite staggering, and I wonder if it could answer other questions about the seismic activity of the Earth or volcanic activity, although they're quite related. But with that kind of movement, with that kind of liquid movement, it surely is having some sort of effect on other aspects of our planet.
Yes, that's right. Yes, exactly. So, the more we learn about our planet, the more we can try and understand the different aspects of it that are well observed, like the reversal of the poles, but as yet poorly understood. So this is, I think this is fantastic work.
Yes,
I'm very impressed.
Yes, it is. And I mean, you talk about the temperatures down there, and I went down a mine many years ago that was quite deep, and it was over 50 degrees when I got to the bottom of the mine, and I was down about 370 metres. And that's just natural heat. It's not because you're down there running engines. That's the natural heat.
That's right.
That only 370 metres below the surface. So you don't have to go far down to start feeling the effects. It's quite warm.
Yeah.
And
we live on a hot planet.
And this is a liquid iron, isn't it?
Yes, it is. Yeah. So the core is iron and with some nickel in it, but iron is the principal component. As I said, the solid core and the liquid core, well established by seismologists. But yes, as time goes on, I mean, maybe we can say, watch this space, because the Swarm satellites might themselves reveal other things about the Earth's core.
Yes, indeed. And we must be nearly due for a flipping of the magnetic field, are we?
Some people reckon within the next 1,000 years, but it's really, it's hard to tell. The magnetic field is certainly reducing at the moment.
Okay.
Very slowly, but yeah.
More to come.
More to come.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program Space Nuts. And this is Space Time. I'm Stuart Gary. China has launched its heaviest ever payload into orbit. Beijing's new Long March 7 heavy-lift rocket blasted off from the Wenchang spaceport on Hainan Island in the South China Sea, carrying the 13-ton Tianzhou-1 supply mission to China's Tiangong-2 orbiting science module.
20秒20秒10 10秒9 8 7 6 5 4 3 2 1点火点火起飞起飞70 190 410分35秒361毫秒着火再着陆112跟踪在电话程序转弯电力阳的信号正常阵地315跟踪正常
Tianzhou-1, which means heavenly ship in Chinese, will spend 5 months in orbit, allowing Beijing to test the techniques needed to dock, resupply and refuel its planned future space station and for its longer-term plans to build a manned base on the moon. As part of the test program, the Tianzhou-1 is conducting 3 autonomous rendezvous with the orbiting outpost. The Tianzhou resupply ships can carry up to 6.5 tons of equipment. That's almost 3 times the 2.35 tons carried by the Russian Progress cargo ship. The Tiangong-2 Space Laboratory is a testbed for the future Chinese space station. Both it and its Tiangong-1 predecessor use the same basic design as the Tianzhou cargo ship, but are equipped with larger solar arrays. The Tiangong-2 has only hosted 1 crew. That was in September 2016 when the Shenzhou 11 docked with the orbiting outpost. The 54-metre-tall Long March 7 rocket combines features of China's Long March 2F and Long March 5 heavy-lift rockets into a single package. The rocket's based around 2 conventional kerosene and liquid oxygen-fueled YF-100 engines on the core stage and up to 4 YF-100 powered strap-on liquid-fueled boosters. That gives it the muscle to propel up to 13.5 tonnes into low Earth orbit and 5.5 tonnes into geostationary transfer orbit. The Long March 7's upper stage uses 4 liquid-fueled YF-115 engines, and further additional stages can be added depending on the payload's flight program. The launch was only the second for the new Long March 7 rocket. It followed a test flight in June 2016 carrying a new prototype capsule for future manned missions. Beijing Space Station, which at this stage is simply known as CSS, will be similar to the former Soviet Union's Mir space station, with the core module expected to be in orbit next year. At least 2 additional modules, carrying crew accommodation, life support systems and docking ports, will be added over the next few years, with the completed space station operational by the early 2020s. Beijing's also planning to have a large space telescope in orbit near the space station, thereby allowing taikonauts to easily replace telescope equipment as needed. That's unlike the Hubble Space Telescope, which is in an orbit some 120 kilometres higher than the space station, which required a separate dedicated space shuttle flight to service the observatory. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.